Okay, so let's look at the negative and the zero rule with exponents. And so we've looked at the product rule and the power rule with exponents, the quotient rule when we divide. But what if we have negative exponents, like 2 to the negative squared or negative 2 power, or we have the 0 as an exponent, like 2 to the 0 power? What does that mean? What do we do when we have those? So let's start with the 0 rule. Start with that 0 rule. So let's think about this real quick. You've got this on your paper. Let's look over here on the left side. So if I had 2 to the first power, you guys think about that. What do we really have? 2 to the first power. And you don't really see the 1 put up there. It's just kind of assumed that that's there when we put it algebraically. But 2 to the first power is just 2. It'd just be like 1, 2. So the same with 7. If we had 7 to the first power, what would that be? If we just had 1, it'd be just 7. Well, here's the deal. The 0 power, anything to the 0 power, and you're just going to kind of have to come to an understanding on this, is going to be 1. 2 to the 0 power is going to equal 1, and 7 to the 0 power is also going to equal 1. Basically, the 0 power says any number raised to a 0 power is 1. And that's any number. We just talked about 2 equaling 1. We talked about 7 equaling 1. Any power. If it was 500, 500 to the 0 power is going to equal 1. And there's some ways we could prove that mathematically, but basically for the sake of time and energy, we're just going to understand that based on the definition and how we work with exponents and the rules, that anything raised to the 0 power is 1. So we want this understanding right over here. Make sure you have it. Just something we want to make sure we've got down. All right, so we've got the 0 rule. Anything to the 0 power is 1. So in this example, I've got 4x squared to the 0 power. Well, 4x squared to the 0 power. Basically, how is that going to come out? It's going to come out, essentially, I can do the long form of it, but it would basically, if I did the exponent here, we'd have 4 to the 0 power times x to the 0 power, because you'd be putting the 0 there with the 4, and then 0 times 2 is 0. So both of these values to the 0 power would just get us 1. Anything to the 0 power is 1. All right, so I think hopefully we've got a good understanding on the 0 rule. Just anything to the 0 power, that is 1, regardless of how complex it looks. Okay, that's how we want to make sure that we are remembering that. Okay. All right, now let's look at the negative rule. So now what if we have a negative exponent? We've done pretty well with the positives, squareds, cubes. We've added, we've done some multiplying with the product rule. We've raised them to powers. All right, but now we've got negative exponents. So let's check this out. You have this on your paper, and so I want you to think about this. We're doing 3, and we're going to start at the top with 3 cubed, 3 to the 3rd power, right? So check this out and think about it. So 3 to the 3rd power, if we start here, what is 3 to the 3rd power? 3 to the 3rd power basically means 3 times, like 3, it's not really working out. 3 times 3 times 3, as you guys know, which equals 27. I was about to write 9, but it's 27. 3 times 3 is 9, times 3 again is 27. All right, what about 3 squared? Well, that's 3 2 times. 3 times 3 is 9. So we're going from 27, we go down to 9. How about 3 to the 1st power? Well, that's 3 one time. Just put a 3 there. That's going to equal 3. All right, so we're basically going down. If you look at what's happening, we seem to be kind of dividing down each time. Let's go. How about 3 to the 0 power? We just learned about the 0 power. What do we get when we do 3, anything to the 0 power? Anything to the 0 power is just 1. All right, so we've basically gone from 27 to 9 to 3 to 1. If you think about that, we're basically dividing by 3 each time. 27 divided by 3 is 9. 9 divided by 3 there is 3, and 3 divided by 3 is 1. All right, well, how does that help us? If you look down below the 1, I've got the negative exponents listed. Okay, so I've got like 3 to the negative 1 power. Well, basically, we're going to continue that rule of dividing by 3. All right, so the way negative exponents work, we kind of have an inverse situation where we end up kind of dividing by 3. almost ending up having like a fraction type thing. So 3 to the negative 1 power, basically what we do is we take this negative part and we basically put a 1 over 3 to the first power. Now 1 over 3 to the first power, since we never really showed 3 to the first power, is just equal to 1 over 3, okay? And if you took 1 and divided it by 3, like we were doing previously, 1 divided by 3, you'd get 1/3, okay? So stay with me, keep going on this. So let's say we do 3 to the negative 2 power. Well, what am I going to do? I'm going to go 1 over 3 to the positive 2. So we put it over 1 and then we take away the negative. So I put it over 1 and then I take away the negative. And then if I basically kind of solve it out, that would be 1 over 3 squared is 9. 3 times 3 is 9. Finally, let's do one more. And we'll do some more of these. So if you're not quite getting it yet, I think you'll start to see what's happening here. I've got 3 to the negative 3rd power. All right, so I see this negative. That means I'm going to put a 1 over, and I can take away the negative now. I put it over 1. It's just going to be 3 to the 3rd. 3 to the 3rd power, 3 cubed, positive. All right, well, let's go ahead and do that 3 cubed and just kind of solve it out of the way. That'd be 1 over 3 times 3 times 3. I'm kind of doing the long form for you guys. 1 over 3 times 3 is 1 over 27. And this is kind of how you apply negative exponents, all right? You put it over 1, and then you can take away the negative value, all right? So here's a little definition. Make sure you have it all the way down. It's a little long, but that's basically what we're looking at. The negative rule. When you have a base raised to a negative exponent, it will be equal to 1 over the base raised to the positive exponent, all right? So in this little algebraic example at the top, x over a negative n is basically equal to 1 over x to the positive n, just like that. That's how we kind of deal with the negative exponent. So make sure you have that down. And then let's do a couple more examples, all right? We'll kind of do some more examples that are a little bit more complex here, all right? So negative exponent rule. And, well, a couple of basic ones, I guess I went ahead and jotted down here. So 2 to the negative 2 power would be basically, I see the negative in there, so I'm going to go 1 over 2 to the 2nd power. 1 over 2 to the 2nd power, which is going to equal 1 over 2 to the 2nd power is 4, and that would equal 1 over 4. All right, let's try the next one. I've got 4 over negative 3 cubed, or yeah, a negative 3 power here. So basically I'm going to go, I see the negative, so I'm going to put 1 over 4 to the 3rd power and make it positive now. Then from here it's basically just about solving it out. What is 1 over 4 times 4 times 4? Sorry, this first one, kind of a smudge, should be a dot. So 1 over 4 times 4 is 1 over, 4 times 4 is 16, 16 times 4 is 64. So you basically turn your negative exponent, get you a fraction as you go. Look at this one on number 3. Look at this one right here, a little bit more complex. All right, so I've got 3x squared to the negative 3. So we're going to do this kind of like the product and power rule that we've done, okay? So I'm going to take the negative 3. First, it's got to go with the 3. So I'm going to have 3 to the negative 3 power, just like that. And then the negative 3 has got to go to that exponent there. So that would give me x. Negative 3 times a positive 2 is a negative 6. All right, so I've written it like this. Now we can deal with the negatives. So now we can do that part where we put it over 1, and then we make our exponents positive. All right, so I know I've got 2 negative exponents here. So let's go. Let's put it over 1. Let's say that's going to be 1 over 3 cubed x to the 6th. And essentially, this could be our solution. We can do this 3 cubed part. We can solve it all the way out if we want to. 3 cubed is 27. 3 times 3 is 9. 9 times 3 is 27. So if I wanted to be really thorough with it, I could say that really simplifies down to 1 over 27x to the 6th. And we can't really do anything with that x to the 6th, but that's how we could take this in a little bit more of a complex example, take it down to that. All right, almost to the end. Let's try maybe 2 more. Just making sure we kind of got this. So very similar to the last one. 3x squared, y to the negative squared, negative 2 power, and we're going to raise it to the negative 3. So what are we doing here? Okay, well, let's write it out. I'm going to take the negative 3, and remember we've got to kind of multiply it to the values inside. So first it's going to go to the 3. So I'd have, go to blue here, 3 to the negative 3 power, like that. All right. Then it would go, the negative 3 would go to that squared, so that would give me x 2 times the negative 3 is negative 6. So 3 to the negative 3rd power, x to the negative 6. And then we're going to take the negative 3 to the squared, the negative squared, I should say, on the inside. So it's going to give me y. Negative 3 times the negative 2 up top gets you a positive 6 now. So this is a cool example because it's going to show you how we do the negative and the positive exponent. All right, so what do? We still do the same thing we've been doing. I've got some negative exponents, so we're going to have to put those, we're going to have to put 1 up at the top as we do that, okay? So I'm going to put 1 over, yeah, let me switch out to the dark. 1 over, all right? Now that can do 3, that negative cube turns to a positive, then x to the 6th. Now, check out this. Y to the 6th power is positive. So that's going to go up top, okay? That wouldn't go down at the bottom because it doesn't have the negative. We don't need to flip it around. So I basically have 1y6 at the top and then 3 cubed x to the 6 at the bottom. The really complete way to put this is to kind of take away the 1 since we have the y6 there and just put this. Y to the 6th power over 3 cubed x to the 6th, just like that. Okay. So basic example here for negative exponent rules, just making sure you put it over 1 and then positive. So make sure, quick review, 0 rules. Anything to the 0 power is 1. Remember, x to the 0 power would be x would be 1. 2 to the 0 power, 1. 500 to the 0 power, 1. Anything to the 0 power is 1. And then we're dealing with those negatives, all right? Dealing with those negatives, put it over, put your, not thanks for watching yet, but put your exponent over 1, and then make your exponent positive, just like that. So remember, 4 to the negative 2 is just like 1 over 4 to the 2nd power, which in this case would be 1 over 16. 4 squared is 16. All right, 0 rule and negative rule.